they are go from pretty much still later, but you need the later. So
Okay, well, thanks for the invitation. And the good team. I'm Johan Potier. I'm the head of data engineering at Tessera Therapeutics here in Cambridge. We've been using Quill for about 2 years. I'm going to speak a little bit about what we do at Tessera and what the context of how we're using Quill. I'm really glad that Greg and others presented today, because there is a few things that I learned and I should have done better and want to do better. So it's really nice to see the context of some of this stuff here. Thanks for setting this up. So Tessera is a gene editing company. The idea is to develop a platform called gene writing. So it's very close to some other gene editing technology you've heard about. But here we were focusing on being able to write full gene of the exon. We are now single beginning Somerville, close to 400 people by now. And we are trying to leverage so-called mobile genetic elements. So these mobile genetic elements are common to all of us, to every species. And they have one very strong ability, is to copy themselves across the genome. They are very aggressive. They kind of cut and paste themselves everywhere. But we are trying to see if we can leverage this technology, program them, and be able to engineer one therapy and then basically cut and paste on what we need to help patient and cure disease. The reason I speak about this is because in order to find these mobile genetic elements in nature, we had a very large screening campaign across a wide variety of gene roles. And after exploring this space, is how do we engineer these mobile genetic elements? How do we use modern genomic technologies to not only engineer these mobile genetic elements, but also transport them into patient and target specific disease that we want to target. And of course, after doing some of that, we need to evaluate the success of this hypothesis with science assay and experiment in the lab that goes from NGS techniques to some others that you're all familiar with. And hopefully we can go through a cycle of this screening, engineer, evaluation, and find something that is useful to patient ultimately. My role at Tessera is really to work with the rest of the data science team and the computational biology team, collect the data from internal, external data source, organize it, and help them to run their computational analysis, and distribute that data. And as we have said, some of the quick feature became really useful right away. How do we implement an analytical pipeline? How do we facilitate exploration? And how do we make it easy for anyone to search and leverage data that we already have? I'm going to focus on some of the NGS assets because that's really what we've been doing from the very beginning. So Illumina instruments upstream, or maybe some CRO company doing sequencing for us. And how do we ingest it? How do we analyze that raw data, process it, and make it available to the rest of the operation? So very typical pipeline. You have like an internal instrument, or maybe some CRO like the Broad Institute or some other companies. You ingest that data, you want it in S3, for people working on AWS. You may have some analytical pipeline, and if you're lucky like we were, Nextflow was already in place, so part of it was already automated at scale, and the output of that analysis in S3 we can. Now, the last mile, I think somebody mentioned it earlier, is the problem. How do you give that report to the scientist? A couple of years ago, it was through Ignite. Many scientists had access to S3 directly, which, as we all know, is not super intuitive. There was no IAM management process, so people are kind of browsing through a S3 bucket, looking for their stuff. Slack messages, emails, the data was all over the place. So how do we make that easy from the beginning? And that's where a quick came in for us. Is really a very quick win was set up quit and just every URL on top of S3. You are changing anything. No packages, no metadata, are just, you don't need access to AWS. You don't need to send a report through Ignite anymore. So that was like the very first step. Go quit and give a link to the users that they could accept their data directly through when you are it. One of the key advantages was, of course, that you have like SSO, infrastructure as code, and all of this from the very beginning. So for us, that was ideal, and that was adopted very quickly at that point. Now we could think of more complex things to do, and Adam and the team from Resilience presented some of this earlier, but we have a similar setup. So instead of having to go base space with Illumina, we changed the setup to have a storage gateway on-prem, so the data will go only on-prem, goes to S3 directly, and we'll let S3 follow the usual process. And then we found some limitation with Nextflow. At the time, the Nextflow quick integration did not exist. So we start looking into data orchestrator like Airflow and others. Decided to adopt Daxter in their case. So that's the little laptop you see on top. So with Daxter, we really started to implement a more like an inland-based system, relying on others told about similar setup. The data lands in the storage gateway. We receive an event that tells us some new data comes in. It syncs to S3 automatically with the service. We receive a second event telling us everything else is synced correctly. And then that's a sensor from Daxter that reacts to it, basically telling us who data is here. From Daxter, call Nextflow, trigger pipeline, process the data, and when the data lands in the output bucket or the output folder, we trigger the creation of the quick package with Daxter again. So I won't go into detail on how Daxter works, but you basically have a set of operations that you put together as a job. And here we have a quit package operation. Basically creating a quit package is a arbitrary folder or set of files that create a package in quit and give us the immutable link output that we cannot use. And in some case, when we automate it to that extent, we can send that link back where the user wants. We have one use case where we send it to the machine directly through the API, so we can just post the quit URL with the proper hash in the machine. So that's one of the most automated use cases that we have. So like I said, with Daxter, we can have like more complex workflows. We can interact with databases, so we use that. We use DynamoDB as well, where we store some of that metadata. We track how we ingest data from CROs or internally, and then we can orchestrate the entire flow, including the creation of the package. And as an output, we get that quit URL, so that as a screenshot you're familiar with when you get raw data from a sequencer. You want to QC that data. Here, the weekly QC report is generated. It's created as a package by Daxter, so we have a timestamp. We have some additional metadata here around the operation, and the users then get that URL and can access the package directly to look at the quality of this monthly. Now, we are trying to enforce more and more data standard in the package. That's one of the things I really wanted to hear about today. There's a lot of flexibility in how you can use metadata in Quit. We have a lot of conversation internally with the computational biology team. What should we store? How do we store it? How do we retrieve it? It's still a work in progress, but we started doing that, and some of that metadata is here then stored in the metadata piece of the query package, and then facilitate the search later on. Just show a quick example here for applicant sequencing, which is one of the most common assets that we do. Basically looking at editing event on a particular piece of the sequence. The data goes to the storage gateway. S3, we call Nextflow, we do like a fast QC on percent code, and then we keep QC report. These generate its own packages. Then when everything is successful, it moves to the applicant sequencing code. It's custom. Again, Nextflow, and when finished successfully, we generate the quick package. So Daxter kind of keep track of all these events, and the quick package keep track of all the metadata at every point, so they can retrieve at a lineage of data provenance. Maybe not the graph database, but that's something we're actually looking into, so that's very interesting to hear. So that's for those of you who are not familiar, that's how Daxter looks at kind of data plane level. You can see the different pipeline when they run. This is the ingestion pipelines for us. That's how we separated them. The QC, the analysis pipeline, and then some of the machine learning specific pipeline. Everything is not always green. That was kind of addition, but at least when you know when something goes wrong, you can see directly and access the different systems that are being called. Then Nextflow is called, so that's more the computational piece. Technically, you could do all of this in Daxter directly if you wanted. Nextflow was here prior to Daxter first. It's also more known, at least, by computational biology, so they can work on their piece of code, deploy new version without interacting directly with Daxter, and that can make it a little easier for everyone. And then we call the Nextflow Tower API just from Daxter. I just code out here all these metadata you see on the right side. So Git hash, Docker version, some of the location. All that information can then be taken out of Nextflow and put into the metadata that you store in Git, so you can search for it later on. And then at the end, you generate the package from Git. So every step generates a package, and each of these packages keeps trying to get metadata from the data of this field. So one thing we're trying to do now is to see that what do we do with all that data? Can we put it together in a way that makes it easy for us to search? Because right now we have to go to Git for everything, which is fine for people like me, not always fine for like the end users. I just mentioned that the reports for us are quite important, not only the QC report and some of the assay-specific report, but integration with things like IGV. Since we're a genetic company, the editing outcome is really important. The integration of tools like IGV directly in Git makes it really easy. So we have a lot of assays where we have to look at editing outcome of a particular experiment. We can display the IGV map directly inside Git. Users can go there. They don't need to open the third-party application. They can look at where was the editing happening. Is the experiment or the hypothesis successful or not? The whole idea is, of course, to take all these reports and put them together into something that makes sense at the scientific level. So if you think about genomic toxicity and all these genotox type of report you need to put together for finding, having them in Git in a way that makes it easy to retrieve and then aggregate and integrate together. The integration is still something we're working on, but at least we can find within a certain namespace in Git all the reports that are related to each other. So that's the piece that for us we are working on now is We use namespace for each of the package, different type of package based on the type of assay we're running, depending what we want to do. We want to extract data from certain package type to integrate them together. And the metadata, not only with automated pipeline, but also our people want to see jobs or just arbitrary analysis. And how can we enforce some of that metadata? Both at the operational level, so conversion, Docker version, maybe Nextflow ID if you use Nextflow, but also some of the benching information, floated ID from the NGS thread, or other type of more scientifically related information. Now, how do we want to define that metadata structure and enforce it? We are still struggling with it, so some of it is here. But how do we find a baseline that's common across all assays, but still keep some information that's specific to each assay type that we can then leverage downstream for secondary and tertiary analysis? Some of the things we've been doing also with Squid, related to what Kai and what Blaze did. We wrote our own API on top of the Grid API to make it a little easier to work with. Mostly because at the beginning, people have to understand what that means, what registry means, how do they interact with particular IDs, what is Grid. We just kind of simplify that. So Tom Davis in the computational team did a huge amount of work on this. That's the part that's great. My team kind of set up the environment, train people, explain what we are doing with it. And then he just ran with it, went to the doc, went with the Quill team, and figured out how to make it easier for him and the rest of his team to use the tool directly. He wrote like a set of classes, Python on top of the Quilt API, create package, find packages, add to packages, extract metadata from them, and then validate the metadata also. Not only how you submit and register your packages, but based on certain, not ontology yet, but really data type, you use Penantic on top of this, so it's Python package you can use it. I'm sure there is many ways to do that. I know there are ways to do that directly in Grid, but in this case, you use this and that kind of fit with the rest of the computational pipeline. And what we're trying to do now is to kind of simplify this and standardize it across Tessera to make it easy for anyone to use it and basically use Squid without having to understand how it works and other members. And one of the last thing he did, which is really nice, is now that we have a new version of code, a new version of pipeline, how do we compare? We make sure that whatever change we did is not impacting the result that we previously had, or if they do, that we're aware of it. So we have an integration test, and these tests are going to be generating their own Grid packages that can look at for reports of change. So we have different level of testing. We can compare pipeline from version to version, but also just number of files that are expected, size of the file, content of the file, and we can go for very fast comparison for minor changes. Just let's make sure that it's just the same number of files, the same size, or a row by row change if we really want to make sure that there is no scientific logic that has been modified. And then these integration tests generate, like I said, their own package, and we have like a nice table basically showing us the differences between files out of this. We are trying to see how can we put that together in a CI/CD type of pipeline to just validate it on the fly. For the time being, it's manually triggered, but that will be enough and then integrate with the rest. I went quite fast, but yeah, Grigori Sterin in the team is the one that did like most of the work, the deployment of Grid and some of the customization. And like I said, Tom in the computational biology team did a huge amount of work to extend how we use Grid at Tessera, and plus the Grid team for everything. But really the adoption in the genomic asset team and the rest of the organization, I think fantastic. So, thank you. After no, go ahead.
Hi, yeah. So it's great that you guys are using Dagster and Xflow. I like seeing the combination of that because at Celerity, we've been using Prefect traditionally for sort of that role of Dagster play. And we're starting to sort of look more into Xflow. I was curious though, for the workflow monitoring, what's the data engineering team at Tessera doing to monitor workflows? Do they use the Dagster interface? Do they use the Nextflow Tower interface? And likewise, the same for your genomics teams.
We use the Dagster interface. So it's connected to Slack notification for now. So it's giving us an alert. So if a Nextflow pipeline crashes, Dagster will be alerted and then send us a notification. It's kind of ad hoc. So at our scale, it's starting to become a small problem of support. But yeah, everything goes to Dagster.
Okay, everybody as well, like your genomics teams, do they also look at through the Dagster interface?
No, the genomic team doesn't interact with it, but the computational biology team does. So the people doing the data scientists in genome will interact with Dagster, and we encourage them to use it as much as they can. So we build the foundational classes and all the jobs and ops in Dagster, so they can just reuse them, like generating your quick package, basically, things like this. And yeah, they're using it directly as long as they know Python and YAML, and then they can onboard. It's been a little easier to use than Xflow directly because of just learning Ruby and everything, but I don't get it.
Thank you.
So where there's the experimental metadata stored, there are also some like sequence information you need to retrieve for the pipeline to run.
Yeah, so we don't store any of that now in the metadata grid. Everything in the file or in the package. So you need to retrieve the package based on some ID or some additional metadata. Then read the content of the package to retrieve sequences.
That's in Quilt or...
That's in Quilt, yeah. So now, instead of interacting with S3 directly, we interact with Quilt and retrieve the objects and read the object. You still have to read.
So and the stakeholders, their interface is Quilt.
Yes. It depends on the stakeholder.
Including genomics team.
Yeah, the genomic team goes a lot to the web UI of Quilt, while the computational biologist goes to the API of Quilt. Depends on who is used what, but at least now they're speaking about the same thing and in the same location.
Station.
Is there any tracking or management of data that lives, outside of S3, or is it the same when S3 is kind of like the source of truth for all data that things get distributed?
So we're trying to have everything in S3 at least. Yeah, everything has to be in S3. While doing the analysis and where you do the analysis, it might be EFS or it could be FSI, depending on what you need. So there's a fair amount of data movements that can be annoying, but in the end, everything has to be S3, at least all like the end of the analysis to be pulled.
I'm really interested in this kind of Dagster, not versus Expo, but this interplay between the two systems. And the part that I don't understand is I always thought of Dagster as the orchestration. Where is the actual compute happening, like the actual number crunch happening? Don't you need Nextflow for that part? Or is there also, are you just running scripts in Dagster, or is the alternative?
So you can do both. Dagster, there are different ways of organizing the work. In our case, all the compute is still happening within our VPC. So Dagster, what you see that data plane is just the web UI that shows metadata. The actual compute is happening inside our VPC, and for us, it's ECS and Fargate. So now, this is nice, it's working well when you do that specific type of job. but it doesn't scale horizontally the same way that Nextflow would, at least in ECS. So since we already had Nextflow and between NFCore and the community on Nextflow, finding some of these like sequencing genomic type of pipeline, much better in Nextflow. You want to try a new single cell, just go to NFCore, you get it, and then you run it, and you see what works for you. And for us, 90% of the time is sufficient to get started. So all we do in that case is having Daxter doing an API call to Nextflow tower, and then run the job. So Nextflow is actually running the job, and we wait for completion of the job. It's just that Daxter provides us a unique interface.
So it keeps being useful to Nextflow tower. Do you still need the Daxter layer?
No, it depends on the type of job that you're doing. Nextflow and tower might be more than enough for what you need to do. But if you need to interact with, say, external databases, if you want to automatically ingest data that is living in a third-party repository, then with Nextflow, you will have to kind of engineer it yourself. With Daxter, you write a small Python class that would just do it, and you will be able to monitor its Daxter. So it's really just a data orchestrator course. It's not, that's it. It's really a nice way to have one entry point to monitor multiple type of jobs, including Nextflow. But the actual scientific logic is only Nextflow.
I have a higher level question of interactions and how we can interact. And again, this is going back to my where I started today with the team of community. How can we convince your team to contribute back some of the things like the wrapper, so that maybe others of this community could benefit? I mean, we're very curious to know how we could work together to make those interfaces. One of the things you said here, so that scientists could use Quilt without necessarily knowing how Quilt works. How could we make it easier to use for someone who doesn't have to learn deep, hard mental models? Something that maybe we struggle with as a team. But is this something that we would need to take up with some leadership? Is this something that you would have with Frida? How do we get this community dynamic jump started? Done.
Yeah, let's go. I don't know. We spoke internally about releasing some things to open source. So it could be as much as the wrapper for Grid as for the things. And there is obviously like a legal aspect, but here there is nothing really secret in what we did. The most difficult part is actually decide what is that we need internally in terms of like the basic. This is how you define a package. That's what the package is. And sounds like Serious did like a lot more work on this, for example. But it is something like this that we need. Okay, this is what we need. We did a lot of back and forth, and we're still doing it on the metadata. So the code we have here might be useful, but would be completely irrelevant to 90% of your users.
Could be something we could work something out. We could try to find ways to fold some of that into future product releases. Based on the learning, see if we could have really productize it.
That was definitely a question for you. So about that. Well, thanks so much. Are there any other last questions? If not,
Yeah, so I know you mentioned the NF core plugin for Quilt. It's something that I haven't actually looked into, but I'm curious, are you guys now using that in your workflows?
No, not yet, but just like we make it easier for anyone to just have a Jupyter notebook and publish a package to it with some of the wrapper that we did. Maybe we can use that. We don't want to enforce DAX, or you have to use Daxter and need to publish with CD. You should be able to publish the quick for anywhere you need, as long as you do it. So, yeah, I read the documentation, but I haven't used this.
Right. Okay. And another question. Sorry, I know you just mentioned that sort of you're trying to encourage the use of S3 for store structured data as much as possible. So does that only apply to your computational teams, or does that also extend to your wet lab folks who, you know, might have various Excel files or whatnot?
Yeah, so
that's the way they go.
Yeah, that's kind of a parallel conversation we have, like what resilience showed earlier. We're trying to use the storage gateway, that storage gateway equals to S3. So we have that same kind of raw lab data giant bucket that has all the laboratory data. But we haven't taken the next step of processing that data into proper packages with proper metadata. I'd like to do that. I'd like to use Quilt as well. Right now, we basically have Quilt on top of that S3 bucket connected to the store and gateway. It's good enough. So the wet lab scientists can go there, can see their files are there, and they can look at some of the file type directly in Quilt, but it's not curated. So it gets messy going.
Yeah, but those folks are, the wet lab folks are
Yes,
uploading the
yes.
files to S3 through Storage Gateway?
Yes. Basically, they put it into like a shared drive or the instrument, dump the data to the shared drive, and they go to Quilt, they see the same folder name. Most of them don't know that it's working behind. They shouldn't have to know, just working nicely. It has its drawback, of course, but it's working better than before when it was in multiple places, including a USB stick.
That's great. Thank you so much.
Thanks enough. 15 minutes.